Let's take a look at Leetcode 10 regex matching. So in this problem, we are given two strings. One is string S, which is a string that can be composed of any characters from A to Z. Let's say string S equals to A. And we have another string called string P that is the regular expression, which can be composed of characters from A to Z as well. In addition, we can use dot character as well as the star character. The dot character can be used to match any single character, whereas the star character can be used to match any 0 or more repeating characters. Let's say P in this case equals to A star. A first intuitive solution would be to recursively compare the first characters in string S and the first two characters in string P. Not all the two characters in string P will be used, but we need to consider the case where it is composed of a character followed by a star character. So let's say we want to implement a match function that takes in a string S and a string P. And we define two characters that matches each other when either A equals to B or B is the dot character. So the first scenario we want to consider is when the first character in string S matches with the first character in string P, and the second character in string P is not the star character. This enables us to recursively call the match function with string S and string P by skipping their first characters. The second scenario we want to consider is when the first characters in string S and string P matches with each other, and the second character in string P equals to the star character. This is actually the case in our example here, where we can search for the case where A star matches with one or more A characters in string S. However, A star could also match 0 characters in string S, so we have to consider the third scenario where P1 equals to the star character, and we don't care what the P0 character is, so that we can recursively call a max function with the same string S and by skipping the first two characters in string P. So this approach is essentially a depth-first search that based on different scenarios by considering the first characters in string S and the first two characters in string P, and recursively search the substrings of string S and string P. However, in this approach, each search branch is not aware of each other and will not be able to use any previously searched result. So it'll end up with a lot of duplicated computation. So let's illustrate with this example here. Let's first define the root of the search. And the first two characters, A star in string P, matches with the second and the third scenario. We recursively call the match function by skipping the first characters in string S and with the same P string. We pass the same S string and skip the first two characters in string P. Eventually, at this third level, we find out that we are calling the mac function twice with the same input, which means we are wasting our resources by calling the match function with the same inputs. So this naturally leads us to think from DFS to use dynamic programming to store the previously calculated states and use that in later calculations. Let's take a look at the approach that uses depth-first search. So we define these two characters matches with each other when A equals to B or when the B character is a dot character. And here is our base condition when P is empty, meaning M is 0. And if S is empty too, meaning P matches with S. Otherwise, we return false. After that, we perform the depth-first search based on the three scenarios we just talked about. So the first scenario is when the second character in string P is a star character, and the first character of string S matches with first character in string P. And then we recursively call the match function for the case where the first two characters in string P matches with one or more characters in string S. And the second scenario we only consider when the second character in string P is the star character. And the case is when first two characters in string P matches with zero characters in string S. And the third scenario is when the second character in string P is not the star character. So we simply match the first two characters in string S and string P, and we recursively call the match function by skipping the first characters in string S and string P. So let's define the inference function for the dynamic programming approach. Let's say dpij is a Boolean value that defines whether the substring of P from index 0 to index j minus 1 matches with the substring S index from 0 to I minus 1. It means whether the first j characters in P matches with the first I characters in S. The dp00 is true, meaning an empty P string matches with an empty S string. When the j's character in P is the star character, which means the last two characters in the substring P can either not match any characters in string S or match one or more characters in string S. Otherwise, we simply match the last characters of the substring P with the substring S, and if they match, we simply assign dpij with the previously computed dpi-1 j-1. Let's take a look at the actual code. So first, again, here we define the char match function where it takes a character A from string S and a character B from string P. And here is the main function that is matching string S with string P. Initially, we calculate the sizes of string S and string P. dpij stands for whether the substring index from 0 to I-1 in string S matches with the substring index from 0 to j-1 in string P. Note that we initialize all the elements in the two-dimensional vector with false, so that here we can start from j is 1 because an non-empty string S would not match with an empty string P. So here we consider if pj-1 is the star character. If it is, we first consider the case where the last two characters in the substring P does not match with any characters in string S. When the last second character in string P, which is pj-2, matches with the last character in string S, which is si-1. If that is the case, we consider the case where the last two characters in the substring P matches with one or more characters in string S. If pj-1 is not the star character, we simply match the last character in the substring P with the last character in the substring S. If they do match, we just assign the dpij with the previously computed dpi-1 j-1. So just to quickly summarize, in this problem of matching a string with a regular expression, we first consider using a depth-first search. However, we found out that it will involve a lot of duplicated search branches, which inspired us to further extend the solution by using a dynamic programming algorithm, where we used a two-dimensional vector indexed by I and j. It stores whether the first I characters in S matches with the first j characters in P. We iteratively build up the two-dimensional vector from bottom up, which gives us the final answer about whether the string S matches with the string P.